We have walked on the surface of the moon. We engineered suits to survive a total vacuum and left boot prints in alien dust. We operate complex robotic rovers millions of miles away, constantly mapping the rocky terrain of Mars in high definition. But when you look back at our own planet from that distance, you see a world dominated by a feature we barely understand.
The ocean covers over 70% of Earth. It produces the oxygen we breathe, and it completely controls our weather. So why haven't we mapped it? Why haven't we fully explored it?
The challenge in space is keeping one atmosphere of pressure safely locked inside your ship against an environment of empty space. This depth gauge illustrates the opposite problem. Water is incredibly dense. As a submarine descends, the actual physical weight of the water above it stacks up, creating tremendous inward force on the hull. By the time you reach the deep ocean trenches, that inward force exceeds 1,000 times the normal atmospheric pressure we experience at sea level. Under those conditions, water's weight becomes a sheer mechanical wall. It acts with instantaneous force, easily crumpling thick industrial metals like tinfoil. A steady supply of oxygen is only the beginning. Reaching these depths requires winning a brutal engineering war against an environment that actively crushes human technology. In the emptiness of outer space, light and radio signals can travel virtually uninterrupted forever. That lack of interference lets us see distant galaxies and talk to probes billions of miles away. The ocean strips all of that away. Because water is dense, it rapidly absorbs and kills sunlight. Go deep enough, and the environment is plunged into absolute freezing blackness. It also acts as a thick, physical wall against radio frequencies and GPS signals. Standard navigation and communication tools break down entirely underwater. Without those signals, the simple act of figuring out where you are becomes a logistical nightmare. That makes accurately mapping the ocean floor vastly more difficult and expensive than mapping the dry surface of the moon or Mars. The deep ocean is a total sensory void. It effectively renders humanity blind, deaf, and disconnected, making a deep descent exponentially harder than flying a probe through empty space. Outer space is a dead, irradiated vacuum. The deep ocean is physically hostile, yet it somehow supports highly complex biology. To survive the extreme pressure and complete lack of sunlight, these animals developed transparent bodies to hide in the dark, skin that generates its own light, and massive teeth to ensure no meal escapes. We find evidence of these adaptations washing ashore or pulled up in nets, like this massive giant squid specimen. Its sheer size and anatomy show how life takes entirely different forms under extreme conditions. Marine biologists calculate that thousands of undiscovered species still exist down there, perfectly adapted to a world without a single photon of sunlight. The deep ocean functions as a complete alien ecosystem, governed by biological rules we do not yet comprehend. It operates as an isolated, hostile planet with entirely different physical laws, located directly beneath our daily lives. Hidden within that darkness are massive geological trenches and completely untouched ecosystems that existed long before human civilization began. We map the stars and connect the globe with high-speed internet, yet we are definitively not the masters of our own home planet. Our collective fear of the deep water comes from a very rational place. It physically exposes our vulnerability and our absolute ignorance. The ultimate alien frontier waits silently in the abyss below, existing closer to home than any star in the sky.